Assistant Professor, Department of Computer Science, working in St.Josephs College of Arts and Science for Women, Osur. Today my topic is Visible Surface Detection Algorithm, subject Computer Graphics. In this we are going to see about back face detection algorithm. What is the goal? The goal of back face detection algorithm is to determine whether a particular polygon or face is facing away from the viewer or facing towards the viewer. This information is crucial for various rendering and optimization techniques such as back face culling. How the back face detection algorithm works? What are the steps we want to follow? First one, normal vector calculation. For each polygon in the 3D scene, calculates its normal vector. The normal vector is a vector perpendicular to the surface of the polygon and it is used to determine its orientation. Next, we calculate view vector calculation. Determine the view vector which represents the line of sight from the viewer position upwards toward a point of the polygon. The vector is usually calculated from the viewer's position to a vertex on the polygon. Next, dot product calculation. Compute the dot product between the normal vector of the polygon and the view vector. The dot product is a scalar value that indicates the cosine of the angle between two vectors. See, this is the algorithm of back face detection algorithm, that is back face determination, continuity of previous. Back face determination, if the dot product is negative, it implies that the angle between the normal vector and the view vector is obtuse, that is greater than 90 degree. This means that the polygon is facing away from the viewer. If the dot product is positive or 0, the angle is acute, that means less than or equal to 90 degree. That indicates the polygon is facing towards the viewer. Back face culling. Once back face determination is performed, back face culling can be applied. Back face culling involves discarding polygons that are facing away from the viewer as they won't be visible in the final render image. This optimization significantly reduces the number of polygons that need to be processed and rasterized, improving overall rendering performance. See in the image that viewer is viewing some polygon image that which is in viewing direction, it will be visible, and others which is in dotted, it is not viewed by the viewer, so it will be deleted or eliminated. The back face detection example. For example, consider a polygon with a normal vector n and a view vector v. If the dot product, that is n dot v, is negative, the polygon is facing away from the viewer. Mathematically, we say n dot v is less than v0, then it is the back face. Next is depth buffer method algorithm. Depth buffer method algorithm. The depth buffer method, also known as edge buffer algorithm, is a widely used technique in computer graphics for hidden surface removal or edge buffering. Its primary purpose is to determine which surface or objects are visible and should be displayed in a render scheme. The algorithm helps in avoiding the rendering of surfaces that are obscured by other objects, thus improving the overall realism and efficiency of the rendering process. The steps of depth buffer method algorithm. Initialization. Allocate a buffer known as depth buffer or edge buffer with the same dimension as the frame buffer. Each pixel in the depth buffer stores a depth value. typically representing the distance from the viewer to the corresponding point in the scene. Clearing the buffer. Set all the depth values in the depth buffer to a large positive value indicating an initially infinite distance. For example, for each polygon in the scene, do the following. First one, projection. Transform the vertices of the polygon from 3D world coordinate to the 2D screen coordinate using the projection matrix. Next, clip the polygon against the boundary to ensure only visible parts are considered. That means after converting the 3D world into the 2D screen, we want to perform the clipping process, that is which is inside the boundary we want to keep, outside the boundary we want to clip or delete it. Next, rasterization. Rasterize is a visible part of the polygon into pixel on the screen. For each pixel, calculates its depth value based on the interpolation of the depths of the vertices of the polygon. First is the depth testing. Compare the calculated depth value of each pixel with the current depth value stored in the depth buffer at the corresponding positions. If the calculated depth value is closest to the viewer, then the stored depth, update the depth buffer with the new depth value and update the pixel in the frame buffer with the color of the polygon. Depth testing, that you want to calculate the depth of the values or images. Repeat the steps 3 and 5 for each polygon in the By following these steps, the depth buffer method ensures that only the visible surface are drawn on the screen. That means which is visible by the viewer, it will be drawn on the screen and the remainings will be clipped. It is a pixel-based approach to the hidden surface removal, providing an efficient and straightforward solution for rendering realistic 3D scenes in computer graphics. One of the drawbacks in depth buffer method algorithm is it needs more memory to store the buffer values. It needs more memory to store the buffer value. This is a drawback of depth buffer method algorithm. There are many algorithms. In this we discuss about depth buffer method algorithms and then backface detection algorithm. In next video I explain 2 more algorithms. Thank you.